Deep in the constellation Virgo, three phantom worlds circle a blinding corpse that constantly blasts lethal cosmic radiation. In 1992, astronomer Alexander Wolshan uncovered something that fundamental astrophysics insisted could never exist anywhere in the universe. He did not find normal alien worlds around a glowing yellow sun, but planets orbiting a dead star core. This was PSR B1257+12, a rapidly spinning pulsar located over 2,300 light-years away from Earth. Pulsars are the collapsed, hyper-dense remnants left behind after massive stars end their lives in catastrophic supernova explosions. When a massive star dies, its core crushes down into a sphere no larger than a human city. Yet that tiny, city-sized sphere packs more mass than our entire sun into an unimaginably tight space. A single thimbleful of this ultra-dense stellar material would weigh over 1 billion tons on Earth. These stellar corpses spin at incredible speeds, sweeping beams of intense radiation across the dark void of space. Like a cosmic lighthouse, PSR B1257+12 flashes precise radio pulses every 6 milliseconds toward waiting radio telescopes. Scientists thought the violent shock waves of a supernova would destroy or eject any surrounding planetary bodies completely. Calculations proved that no planet could survive the sheer heat and physical force of such an explosive event. Yet, subtle anomalies in the pulsar's radio pulses revealed an undeniable gravitational pull acting upon the star. Something massive was tugging on the dead star, causing its ultra-precise timing rhythm to waver very slightly. Detailed mathematical analysis soon confirmed the shocking truth. Multiple alien worlds were orbiting this radioactive cosmic lighthouse. Astronomers named these impossible survivor worlds Draugr, Poltergeist, and Phobetor, after terrifying legendary figures of death. These were the very first exoplanets ever confirmed in human history, changing our understanding of the universe forever. Before this discovery, humanity believed planets could only form around calm, living stars, like our own sun. Finding alien worlds around a violent stellar corpse raised a terrifying question. How did they get there? Did these planets somehow survive the catastrophic explosion, or were they born from the resulting cosmic ash? To understand their mystery, we must step onto the desolate, scorched surface of the planet named Poltergeist. Poltergeist is a rocky super-Earth, possessing a mass roughly 4 times greater than our home planet Earth. The sky above Poltergeist never features a warm, gentle sun to illuminate its vast frozen landscapes. Instead, a pinprick of searing white light casts harsh, razor-sharp shadows across icy plains and jagged mountains. This tiny stellar core drenches the entire planet in continuous, lethal doses of high-energy X-ray radiation. Charged subatomic particles stream along powerful magnetic field lines, creating immense, perpetual auroras across the sky. These glowing atmospheric curtains would be a magnificent sight, yet completely deadly to any organic life. Orbiting nearby is Phobetor, another massive world bathed in the exact same hazardous stellar environment. Phobetor circles its dead host star every 98 days, traversing a frozen and radioactively sterile zone. Closer to the pulsar lies Draugr, a tiny planet with a mass similar to our moon. Draugr completes a full orbit in just 66 days, enduring the most intense radiation bombardment. The existence of 3 distinct worlds in stable orbits proves these are not random captured asteroids. They form a true planetary system, orderly and precise, yet existing in a place of complete cosmic destruction. For years, astrophysicists debated whether original planets could actually survive a giant star's violent death. As a massive star runs out of nuclear fuel, its core collapses in less than a single second. The resulting shockwave tears through the star, blasting its outer layers into space at unbelievable speeds.
Any inner planets orbiting the original star would be completely engulfed and vaporized by superheated plasma. Outer planets would likely be hurled into deep space as the star suddenly loses most of its gravity. This realized impossibility led scientists to forge a radical new theory regarding the origin of these worlds. What if Poltergeist and Phobetor were not ancient survivors, but secondary planets born after the explosion?
During the supernova, some blasted stellar material failed to escape the gravitational pull of the core. This fallback debris settled into a dense, rapidly spinning disk surrounding the newly born pulsar. Over millions of years, gravity pulled this radioactive ash together, forming brand new rocky planet seeds. These worlds were literally forged from the dead body of the massive star that preceded them. This second-generation planet formation process means planet birth might be far more resilient than ever imagined. However, the environment on these reborn worlds remains among the most hostile in the known cosmos. The pulsar's intense magnetic field accelerates subatomic particles to nearly the speed of light continuously. This relentless relativistic wind constantly batters the surfaces of Poltergeist, Phobetor, and tiny Draug. Any water or atmosphere present during their formation should have been stripped away into space long ago. Yet, computer models suggest these planets might possess exotic surface compositions, completely alien to us. Under constant high-energy radiation, carbon-rich materials on the surface could transform into vast fields of diamond. Immensely thick glaciers of solid carbon dioxide and exotic ices might cover their dark, frozen landscapes.
If an observer stood on Poltergeist, they would witness a sky devoid of warmth, filled with glowing magnetic storms. The landscape would shine in strange fluorescent colors as high-energy particles hit exotic surface minerals. Silence would reign supreme, broken only by the invisible, deadly rain of cosmic radiation pouring from above. The discovery of PSR B1257+12's planets forced astronomers to look for pulsar worlds elsewhere in our galaxy.
In 2003, another extraordinary pulsar planet was confirmed in the heart of a dense globular star cluster. Nicknamed Methuselah, this ancient world orbits a binary system composed of a pulsar and a white dwarf star. Methuselah is over 12 billion years old, making it more than twice the age of our own Earth. It formed shortly after the Big Bang, proving planets could exist almost as early as the universe itself. These discoveries demonstrate that planetary systems are surprisingly tough, surviving conditions once thought completely lethal. Yet, pulsar planets remain incredibly rare, with only a handful ever discovered among thousands of known pulsars. Special conditions must occur during or after a supernova explosion for pulsar planets to successfully form and endure. If the fallback debris disk is too thin, material simply disperses into space without ever forming new worlds.
If the pulsar's radiation wind is too strong, it completely blows away the planet-building dust disk entirely. Poltergeist and its sister worlds represent a precise, delicate balance between cosmic destruction and secondary creation. They are true phoenix worlds, literally rising out of the vaporized ashes of their dead parent star. Could life ever exist in such an extreme, radioactive environment, beneath a perpetually dark and violent sky?
Traditional carbon-based life as we know it on Earth would be instantly destroyed by the intense radiation. However,
Astrobiologists speculate that exotic subsurface life forms might adapt using thick ice layers for protection. Internal geothermal heat from radioactive decay inside the planet's core could keep underground liquid oceans warm. Deep beneath miles of solid ice, alien organisms might thrive without ever knowing a warm sun exists.
These dark ocean ecosystems would rely entirely on the internal heat of a planet born from death. As technology advances, next-generation space telescopes will study these alien dead star systems in unprecedented detail. They will measure magnetic interactions and search for subtle atmospheric signatures around these radioactively battered worlds. What we learn from Poltergeist and Phobetor reshapes our entire understanding of planetary survival across the cosmos. It proves that even when stars die in catastrophic explosions, the story of worlds is far from over. Nature finds a way to build new worlds in the most impossible, terrifying, and hostile environments conceivable. Poltergeist and Phobetor remain silent monuments to the endless, indestructible cycle of cosmic rebirth and creation. Out in the dark depths of space, dead stars continue to light up worlds we never thought could exist.